Hello everyone, welcome to the first lecture series of Sensor and Instrumentation with the basic introduction of sensors and transducer. In this lecture, we will see what are the sensors and how they are different from the transducers. My name is Deepti Singh. I'm an assistant professor in Department of Electronics and Communication Engineering at Ajay Kumar Garg Engineering College. So let's start. First, let's see what we have in this series. Like first, we see that how sensor and transducers are different and what are they. Then we will see the classification of how we will classify the sensors, what are the measurement, how we measure the displacement, force, pressure, and with different sensors. Then we see what are the measurement of temperature, position, flow, level using different sensors. Then what is the concept of virtual instrumentation? That is a very interesting topic. Then what are the data acquisition technique? And last, we will go to the intelligent sensors and its application. So if you prefer to go through the books, these are the standard books that I prefer. That is the Modern Sensor Physics Designs and Application by Jacob Fredden, Understanding Smart Sensors by Reddy Frank, then Sensor Technology Handbook, there is a Science from Science Direct. Then if you prefer the university prescribed book, it is a DVS Murthy, Transducers and Instrumentation, D. Patnabis for Sensor and Sensor and Transducer, S. Gupta, GP Gupta for PC interface for data acquisition and process control, Gary Johnson for LABVIEW graphical programming tool. And for the reference book, I personally prefer Arun K. Ghosh, Introduction to Measurement and Instrumentations, A.D. Helfig and W.D. Cooper for Modern Electronics Instrumentation and Measurement Technique, and Herman K.P. Newbert for Instrument and Transducers. So moving to the sensors in our daily life, and I know you all have the cell phone with you. Then if you use your cell phone on a daily purpose, or I think in a hourly purpose, you see there are too many sensors available in your phone itself. So what are the sensors that are available? That is a proximity sensor. Suppose you touch, even there are some phones that can on, their light can on just to the touch. That is a proximity sensor. Then there is an ambient, which can be depending upon the source of energy. Like if you on the bulb, or if you put your phone in a light condition, then it will the screen is on. Then if you off the light, then the screen is off. So something like that also there. Then there is the image sensors. Then there is a GPS sensor for your locations, accelerometer for the movement. For your movement, you see many people have the phones that can calculate your number of steps. Then how it's possible? Then we have a humidity sensors also, like you can see the temperature and the humidity around for your surroundings. Then we have a microphone, obviously, for speaking. Then we have a touch sensors that is available for last decade. We see there is a increasing demand of the touch phones. Then we have a gyroscope. Then we have a magnetometer, fingerprint sensor. There's a pressure sensor, there's a temperature sensor. So you see in a single device, there are so many sensors, like more than 10, 20 sensors are available. So similarly, if you see about your human body, we know that there's a 5 sensing element that is present in our human body. That is a sight, which is capturing the images, our eyes. Then there's a smell, which is captured our nose, by our nose. Then taste, it is captured by our tongue. Then there's a touch sensors for our skin. Inside our skin, we have a sensor. Then there's a hearing. We can sense the sound. So these are the sensor that is present in our human body. So as a body, we are all made up with some kind of sensors. So what are sensors? The word sensors comes from a Latin verb sensitare, which is meaning to feel or to perceive, combined with a Latin suffix or that indicate agent or tool. So according to the American National Standard Institute, a device which provides a usable output in response to a specified measurement, which is known as a sensor. Means if you a device that can sense your surrounding and it will give you some output, some usable output, is known as a sensor. So what the sensor do? It acquires a physical parameter and converts it into a signal suitable for processing. For example, optical, in the form of optical, electrical or mechanical parameters. So a sensor is a device that receives a stimulus and respond with an electrical signal. Now, what kind of stimulus it can have? It can be a acoustic, it can be a biological, it can be a chemical. In the form of acoustic, we have wave like amplitude, phase, polarization. In biological and chemical, we have fluid concentration. Then in terms of electric, you see there is a charge, voltage, current, electric field, conductivity, permittivity. Then magnetic, in terms of magnetic field, we have again flux, permeability. Then in optical, refractive index, refractivity, absorption. In terms of thermal, temperature, flux, specific heat, thermal conductivity. In terms of mechanical, we have position, velocity, acceleration, force, strain, stress, pressure, torque, with a very important parameters that. So you see, any kind of parameter can be detected, can be measured using sensors and transducers. So I use the words transducer as the sensor and transducers are the analogical words. You see, we will discuss in later that what is the difference between a sensor and transducer. These are some kind of sensors that is available that you go through as a student in your laboratories. Like we have a IR sensors, we have touch sensor, we have a humidity sensor, that is DHT11. Then we have a gyroscope, we have a photos transistors, we have water flow sensor, we have IR receiver, we have ultrasonic sensors. This is a proximity sensor, we have a gas sensor, we have a heartbeat sensor, there is a range sensor, there is a smoke sensor, there is a LDR, that is a light dependent resistor. Then we have a soil moisture. I think these all you have. These LM35 for as a temperature sensor. So I think if you make a little project or some kind of you are working on a hardware, you've gone through some of these sensors in your student life. Then let's classify the sensor. Now sensors has been classified between two categories, like the broad category as an active sensor and a passive sensor. Active sensors are those which require the external power supply. Means they need external power for their operation. This is the external supply is called excitation signal, and this signal is modified by the sensor to produce the output signal. So it is called a parametric because their own properties change in response to the external effect, and these property can be subsequently converted into an electric signal. For example, a thermistor is a temperature sensitive sensors, and it generates the electric signal in the form of like a change in the resistance. So whenever there is a excitation, you have to give some voltage for it to provide. So whenever there is a temperature like in the proximity of that thermistor, its resistance changes due to heat, and due to heat the resistance change has been detected by the sensors and will be given the output in the terms of voltage. So this is known as the active sensor. Now what are the passive sensors? It does not need any additional energy source and directly generates an electric signal in response to an external stimulus. That is, the input stimulus energy is converted by the sensor into the output signal. For example, we have a piezoelectric sensor, which is a great example of passive sensor. What are the piezoelectric sensors? You just provide the force on a piezo because of the construction of their the material, the piezoelectric material, which you know that we have a crystal. We have a crystal and piezoelectric crystal, or we have a Rochelle salt that is kind of a piezoelectric sensor, material. And the piezoelectric sensors are made of these kind of material. So they have the ability to change their electrical conductivity in terms of the vibration. So whenever you provide some pressure or force at these material, their internal structure has been changed, due to which the charge has been generated, and that charge is converted into a output voltage. So these some kind of like photodiode works on the principle of photoconductivity, like the photons enters into the device, and it has a photoelectric material. So the energy has been converted, the photon energy has been converted into electric current. So they are the photodiodes. So these are some example of passive sensors. Now based on how you compare or how you measure the parameter, the sensor has been divided into absolute sensor and a relative sensor. So absolute sensors are measure stimulus against the absolute physical scale, independent of the conditions. So for example, thermistor measure the Kelvin scale. Absolute pressure sensors, that they measure the pressure as compared to the atmospheric pressure. So it detects the stimulus in reference to an absolute physical state, that is independent of the measurement conditions. In comparison to that, relative sensors are measures stimulus relative to the reference or baseline, not absolute zero. For example, a thermocouple, it needs a reference. Gauge pressure sensor relative to atmosphere, it produces an electric voltage which is a function of temperature gradient across a thermocouple wires. So thus the thermocouple output signal cannot be related to any particular temperature without reference to the known baseline. So another example of absolute sensor that produces signal reference to vacuum, and absolute zero or pressure sensor. So these are the kind of sensor. Now we will go to the some physical principle, like how our sensors has been what are the working principle of our sensors. So depending upon the sensors, the working principle has been changed. For example, the Ampere's law. Some sensors follow the Ampere's law, that is a current carrying conductor in a magnetic field experience a force. That is, for example, galvanometer, it is a device. Then Curie-Weiss principle, that is there is a transition temperature at which ferromagnetic material exhibit a paramagnetic material. Then we have a Faraday's law of induction, like a coil resists a change in a magnetic field by generating a opposite voltage, which we call EMF. Then photoconductive effect, when light strikes certain semiconductor material, the resistance of the material decreases. For example, photoresistors. Now, why we need a sensors? What are the applications of sensor? Why the world need a sensors? So these are the sensors are used in every aspect of life, like in agriculture. You see, there is a concept of smart agriculture using an IoT device. How it can be possible without sensing the real-time parameters? So for measuring the real-time parameter, you need a sensors. In terms of manufacturing in you need to analyze the current situations of the structural sites. So you have to know that how much if there is a cement is you see the making of RCC cements, whether it is not temperature increases or not, what should be the mixture, how much should be the mixture, how much water intake it should have, how much moisture absorption it should have. So all these parameters can only be measured by the sensors itself. Now, in terms of our automotive vehicles are made of thousands of sensors. You see, there is a speedometer, there is a flow sensors available, there is a pressure sensor available. And now we have a touch sensors, we have a ultrasonic sensor, we have a laser sensor. There's 1,000 kinds of sensor available in your automobile car. Then obviously for industrial applications, we have in that category we say that it is a combination of sensors and instrument, but industries still need sensors. Then there's the aviation industry. You see the cockpit is full of sensors. Then we have a medical and healthcare industry. There's a biomedical sensors available. Then we have environment and monitoring. There are so many environment sensors are there. Then in a marine industries also. So I don't imagine a world without a sensor. Even our body needs a sensing element. Then Yeah, what is the difference between a sensor and a transducer? You people sometimes heard about, some people say it is a sensor, some people are say it is a transducer. What is the difference between a sensor, these two terms? How they are, if they are used in terms of like in place of one another? No. These are some condition that you can use the term sensor, and there are some condition there you can use a term transducer. If you see in later part, we will see the what is the structure of measurement. In that we see that most cases sensors are some that actually capture the mechanical energy and convert that mechanical parameter into some kind of mechanical parameter or the electrical parameter, and transducers convert that mechanical parameter into some kind of electrical parameter, something like that. So if we go by the definition, the sensor detects a physical change and converts to a signal, some kind of signal, whether it is a electrical signal, whether it is a mechanical parameter, we don't know. Then transducer are defined as which converts one form of energy to another form. It is not something like from one electrical parameter to a mechanical parameter. It is not like that. Then we have a standalone sensing element, like sensors plus signal conditioning circuitry. Sensors only have one standalone sensing element, but transducers have the signal conditioning plus sensor. So sometimes sensor is in the transducers system. Sometimes we say sensor is a primary transducer, and the next signal conditioning circuitry is known as the secondary transducers. Then we say in terms of primary functions, it measures or sensors a physical quantity. In terms of transducer, we say that energy conversion from one form of energy into another form. Then output signal, usually a raw analog signal, but transducers can provide analog or digital output both. But sensors will only provide the analog signal most of the times. Then need for signal processing typically requires additional processing circuit. But transducer usually output ready without an extra processing. Energy conversion may or may not involve energy conversion in terms of sensors, but transducer is always involved in the energy conversion. Complexity, sensors are mainly very simple device, but transducers are more complex than and it involves very heavy circuitry. Then bidirectional capability, sensors are not bidirectional, but transducers are bidirectional. They are inverse transducers possible. Then examples, for example, temperature sensor, proximity sensor, but transducers are thermocouple, microphone, piezoelectric sensors are transducers. Not the sensor you have, like you have a piezoelectric, you see, if you provide some force in, it will change into some kind of electric signal, but if you provide an electric signal, it will not vibrate. But in the transducers, in transducer, you will see that if you provide an electric signal, then it will vibrate. Then, what are the transducers? Transducer is a device that converts one form of energy into another form. It takes a physical quantity like pressure, temperature, sound, or light and converts it into a usable signal, often as electrical signal, that can be measured, recorded, or processed. So, input connect with the sensor first. So, first, I already told you, it is like a primary transducer. So when the input is coming, it will first detected by the sensors or primary transducer. Then it will convert it into a transaction element, that is a secondary transducer, and then it will provide output. So mainly inputs are what? Resistance, capacitance, inductance, stress, strain, heat, mostly. And output should be the force, displacement, pressure, sound, magnetic flux, voltage, or current. So if you go through how the sensors and transducers are seen, you see a transducer is this. It has a sensing element plus a transaction element, that is a signal conditioning element within itself, and this is a sensor that you usually used in your laboratory experiments or some your like IoT based projects. You see these kind of sensors. So it is a gas sensor, and you can see it, but this is a difference between a sensor and a transducer. Now what are the classification of transducers? So transducers are classified into a different kind of depending upon what kind of application you are using. For example, based on energy source requirement, you have active transducers and passive transducers. As the sensors are the active sensors which require the external power supply. Transducers are mostly the opposite. The active transducers are those which does not require the external power supply for the conductions, and passive transducers are those which require a power supply, external power supply. So based on the physical phenomena, there are primary transducers and secondary transducers. I already told you. Based on its output, analog transducers and digital transducer. Based on the transaction phenomena, we have a transducers and inverse transducer. Basically, transducers, we say that it mainly convert the mechanical energy into an electrical energy. So when the electrical energy is converted into a mechanical energy by a transducer, then we say that it is a inverse transducer. Okay, but fan is not a transducer. Next, based on the construction, mechanical transducer, electrical transducers, optical transducers. Then we have what are the characteristics of sensors. So the sensor characteristics are converted into a static characteristic and dynamic characteristic. But inside a static characteristic, we have a desirable characteristic and undesirable characteristic. So the dynamic characteristic we have in a desirable format, speed of the response, fidelity. Undesirable, that is a dynamic error or lag. Similarly, dynamic characteristic are which changes with respect to time. So basically, when the output is changes or the input has been changed with respect to time, we go for the dynamic characteristic. But mostly the sensor where are in a static characteristic format. So for a desirable form, we have accuracy, precision, sensitivity, reproducibility, static error, resolution. These are our desirable characteristic. Undesirable characteristic are drift, dead zones, dynamic error, hysteresis. These are the undesirable characteristics. Then if we see what are the accuracy, it is the closeness of the sensor output to the true value or the actual value. For example, suppose you have measured some value by experimental purpose through experimental method and through a theoretical method. So whatever the theoretical method you have come across, it is the actual value, and whatever the experimental you concluded by the experimental procedure, it is a measured value. So mostly the measured value minus true value upon a true value is known as what we say the error, percentage of error. But accuracy is if we minus 1, then it is something like accuracy, how much accurate your sensor is having. So for example, thermometer showing 100 degree when actual boiling point is 100 degree is the 100% accuracy. Now similarly, we have precision, that is ability to reproduce the same result under identical conditions. Suppose you are experimenting and you got the result many times. You have 1, 2, 3, 4 times of testing. Then after 4 times of continuous experimentation, you get the same result for the same input you are providing or same environmental condition you are providing. Then it is known as your precision. So precision is mostly plus minus k into sigma, that is standard deviation. Okay. Then we have a sensitivity, that is change in the output signal upon change in the input signal, that how much the output has been changes with respect to the change in input. It is known as the sensitivity. Resolution, that is the smallest desirable input change that has been detected by the for that you can get the output, is the resolution. Reproducibility is same, the ability of sensor to produce the same output repeatedly over time for a same input. So reproducibility and precision are like same thing. Precision is mostly known as repeatability, and and it is known as reproducibility. But the difference is that that under the same condition. But reproducibility, mostly you can use like over a same input, but mostly not in the same environmental condition like. So static error, the deviation between the measured value, true value, under steady condition, it is a static error. Then undesirable property, that is drift, variation of output with time under constant input, it is a drift. Dead zone, that is range where input does not produce any output, is a dead zone. Then hysteresis, the difference in output for the same input depending upon the approach. You see that if we increase the input and how we get the output, then we decrease the input and the output will not be follow the same path. It is the hysteresis curve. We all know that. Then speed of the response, these are the dynamic characteristics basically, that if the digital if you see that how fast your response is. Suppose you have put your thermometer in like connect your thermometer with some temperature with some material, and the reading quickly started to change. That means it is a high speed response, but if it takes some time, then it is that the response time is slow. Then fidelity, that is ability to faithfully produce the input signal at the output without distortion. So that is called the fidelity. Then dynamic error, difference between the actual sensor's output and the true value when input changes with time, is the dynamic error. Then lag is time delay between the application of input and the sensor output reaching the true value. Then choosing, how to choose a sensor. If you know that how much the sensitivity, stability, accuracy, speed of the response, you overload characteristic, hysteresis, operating life, cost, size, weight, then stimulus range, what are the resolution, what is the selectivity, what is the environmental condition, how linear is that, dead band is there, output format, and others for choosing the sensor. For example, a school wants to reduce the electricity use in a classroom by installing a smart light system. The requirement are light should turn on when someone enters the room, light should stay off if natural light is sufficient. System must be reliable, low cost, and easy to maintain. So first if we use a PIR sensor, then the detect occupancy, ceiling placement at the ceiling center. Logic flow, if motion detector, check light sensor, if dim, turn on. Pros, low cost, reliable. Cons, misses stationary occupant. Justification, best for the movement detection. Then we have a photo detector, which purpose is measure daylight. Placement is wall near window. Logic flow, if daylight sufficient, keep lights off. Pros, simple, accurate. Cons, need proper installation. Justification, ensure daylight use. Then we have a manual switch, override or system. That near door allows manual on and off control of safety and convenience, user control, and may reduce efficiency needed for safety. So these are the comparison that how you will choose because we need a low cost or we need a simple accurate. Okay, thank you so much.